Session 3.4 is about find the zeros of polynomial function. Now we know what a polynomial function is, and we looked at different ways of finding zeros. Quadratic formula, if it's a quadratic function, if it's more than that, use the division, factoring. So in here we're going to look at different theorems. So one of the theorems is called rational zeros theorem. So let P of x is a polynomial with this format, general polynomial format. And they have to have an integer coefficient. That means these a sub n's have to be integer. If p of q is rational zero of p, then p is a factorial constant coefficient of zero, a sub zero, this, and q is a factorial a sub n. So what we do is you look at all the possible rational zeros. So in here, list the possible rational zeros of this polynomial 3x cubed minus 2x squared minus 8x plus 4. So let's look at all the possible factors of 4. You have positive and negative 1, positive and negative 2, positive and negative 4. For q, it's a factor of 3, positive, positive and negative 1, positive and negative 3. Then you just find a way to divide them. 1 divided by 1 is 1, 2 divided by 1 is 2. The negative and positive versions of those. Negative positive 4 divided by negative positive 4 is 4. Then you're 1 divided by 3, 2 divided by 3, 4 divided by 3. Those are all the possible rational zeros. So, well, what are the actual zeros? Well, in this case, it will be 2 over 3, 1 and negative 2. To find it, you can use a synthetic division. So you have 3x cubed minus 8x squared plus 8x plus 4 divided by x minus 1. So we write it as in this format. So this should be just a positive one. So 3, 1, negative 8, 4, bring down a 3. 3 times positive 1 is 3. 1 plus 3 is 4. 1 times 4 is 4. You get negative 8. Negative 8 plus 4 is negative 4. 4 times 1 times negative 4 is negative 4. Use 0. So you got 3x squared plus 4x minus 4. Well, from there, you could factor that to 3x minus 2, x plus 2, and so for 0. You get 1, 2/3, and negative 2, which is right here. Okay. So look at this problem. We have x cubed minus 3x squared plus 4. Look at all the possible rational zeros. I find the factors. Plus or minus 1, plus or minus 2, plus or minus 4, over plus or minus 1. To this divided, you get plus 1, plus or minus 1, minus 2, plus or minus 4. And if you use the synthetic division, you could find the actual zeros. So you have 1, negative 3, since you have no x's, 0, 4. So 1 times negative 1, bring the 1, you get negative 1. Add them, you get negative 4, 4, 0. So you get x squared minus 4x plus 4. You go for 0, you get x equal negative 1 and 2. Okay, factor p of x as x to the fourth plus 2x cubed plus 2x squared plus 2x plus 1. Well, since this is a 1 and this is a 1, the possible has to be plus or minus 1, and 1 would not work. So we're going to use the division. 1, 2, 2, 2, 1, divided by x plus 1. So you get 1, 1, 1, 1, 1, 0. That's the same thing as x cubed plus x squared plus x plus 1. You get this. You could factor this out again, you will get x squared plus 1, and it's going to be x plus 1. So x plus 1 times x plus 1 plus x squared times x squared plus 1. What are we going to do with this one? This x squared plus 1. If you use a quadratic formula, it won't give you no real zeros because right here you get -4. And you know that I equals square root of -1. So if I were to solve it, I get square root of 2 over 2i, and you get plus or minus I. And that's why you get something like this, x plus 1. Okay. The fundamental theorem of algebra says every polynomial of degree 1 or higher has at least one complex or possible real 0. So if you pair this with the factor theorem, it gives the amazing result that every polynomial with complex coefficients can be completely factored into factors. So right here, we have this polynomial with complex coefficients where n is greater than or equal to 1 and n sub n is not 0. Then there are complex numbers a, c1, c2, such that the polynomial of x is equal to a times x minus c1, x minus c2, blah, blah, blah. The number of times the 0 appears is its multiplicity. So what they were saying, if you use a complete factorization theorem, and your n is greater than 1, and your n is not 0, then we can have this format. Polynomial x is equal to a random number, a given complex or real, x then x minus ac1 plus c2, and until that series is completed. So look at the factor, find complete factorization of p of x for this polynomial. And we're going to use a rational zeros. So you have plus or minus 1, plus or minus 1 half, plus or minus 2, plus or minus 3, plus or minus 3 over 2, plus or minus 6. Now, if I was to graph it, I get this. Now, if you look at the graph, the p of x, and so you have 0 at -3 and 0 at 1 half. If I use synthetic division, I get 2x, after completing the division, I get 2x cubed minus x squared plus 4x minus 2. So this part over here. And you could factor this out, you get 2x squared plus 4. Well, to factor this out, I'm going to have to use this. Z equals 0, x equals square root of 2i. So 2 times x plus 3, x minus 1 half, that's my zeros, x minus square root of 2i, x plus square root of 2. Okay. When we factor an irreducible quadratic, we always get a pair of complex zeros or conjugates. So this leads to the complex zeros theorem. If P is a polynomial with real coefficients and the complex number z, a plus bi, is a zero of P, then z naught or a minus bi is also a zero of P. This is what they're saying. If you have a complex number, a plus bi as 0, then a minus bi is also 0 because complex zeros are conjugates. You have a positive version and a negative version. So right here, find a polynomial with a degree of 4 that has zeros at 0 and 1/4 and 3n, and such that p of 1 equal 30. So we need to find zeros at for all those three rows. So you have 0, 1/4, So, and 3i. This 3i is plus or minus 3i. So if I were to solve it, so you could just a, there is some number, x minus 0, x minus 1/4, x minus 3i, x plus 3i. Now you do FOIL to get this, x to the fourth plus 9x squared minus 1/4, x cubed plus 9 4x. I could multiply the whole thing by 4 to get a general formula, 4x4 minus 3x cubed minus x cubed plus 36x squared and 9x. That's the P of x. Now I want to check if P of 1 equals 30. So plug in 1 and check if it's equal to 30, and you solve for A, you get 4. Give me a solve it. That's question 3.4.